Assalamualaikum warahmatullahi wabarakatuh. And very good day. So we meet again. So this is topic 2, part 2, which is the transmission line. So the objective of this topic is listed as can be seen in the screen. Okay, the first one is the student should be able to list and describe various type of transmission lines, discuss basic concepts related to design and structure of power transmission line, identify transmission line parameters, and model the lines into suitable line representative. And the last one is to analyze power flow and performance of line in terms of efficiency and voltage regulation. So as an introduction, so transmission line is a component in power system which connect the generation power stations to distribution sections and consumer. To reduce power losses in long distance transmission line is operated at very high voltage, meaning that it is from the generation power plant, it is stepped up using transformer, okay, to reduce the current so that the losses is reduced. Most long distance lines are overhead lines due to cost and technical considerations. However, there also exist underground lines or submarine cables used to transmit power across congested areas or river or sea. Conductors for the transmission line in general are made of aluminum or copper. The copper has better conductivity per unit of volume compared to aluminum, but is more costly and has worse conductivity per unit of weight. So, even though the copper has better conductivity, but it is not preferable due to the cost. Thus, aluminum is widely used as power line conductor compared to copper. There are 4 types of aluminum conductors that typically use. Okay, the first one is what we call all aluminum conductor, or in a short form is AAC. All aluminum alloy conductor, AAAC or triple AC. Aluminum conductor steel reinforced, ACSR, and aluminum conductor alloy reinforced, ACAR. Aluminum conductors supported by alloy are commonly used because the combination of the materials increase the conductor strength. Okay. So figure, this one show the cross-section view of a sample of the aluminum core, aluminum with the aluminum conductor, steel reinforced conductor. Okay. So this is the cross-section. So there are 7 steel conductors in the arrangement that form the core to strengthen the ACSR conductor. So the 7th steel conductor is actually in the middle, and the steel core is surrounded by 24 aluminum conductors. Okay, this arrangement is stated simply as 24 AI, which is stand for aluminum, 7 ST. This one actually is actually represent the steel, or 24/7. Conductors used for high voltage overhead transmission line are typically bare, which is uncovered. Okay, there is no insulation. So in all, this is actually done to ease the heat dissipation to the surrounding and reduce the weight of the conductors. The line is only insulated by the pin insulators that are suspended on the transmission tower and by the air surrounding the conductors. The pin insulators are normally made of porcelain or glass and also form the support for the conductor to the tower. While for the underground conductor, this should be well insulated because underground has a lot of what we call external elements such as water, soils, and so on. So for the conductor cable, should be well insulated compared to the overhead cable. So this is the difference between the overhead cables used for the transmission for the overhead, and this one is for the underground line. So the difference is that for the overhead transmission there is no insulation. Okay, actually the conductor is actually bare, while as you can see here we have the center is the steel and surrounded by the aluminum conductor here, while the underground cable, as you can see, it must be protected with several layers of insulation. So overhead lines. So power is mostly transmitted by overhead line because of the cost. Okay, the overhead line is the cost is much cheaper compared to the underground transmission line. The conductors are not insulated. Okay, as previously described, is not insulated. Is only insulated by the pin insulator at the transmission tower. While the underground line, as shown in the figure here, are used to transmit across river or sea or through dense populated areas. The lines, which is the underground cable, are not suitable for high power applications because the heat for the underground cannot be dissipated very easy. High voltage alternating current lines or HVAC. So HVAC lines using three-phase conductor arrangement is used to transmit power at high voltage to distribution section. Relatively low AC voltage at generating stations are increased by step-up transformer to high transmission voltage. In Malaysia, there are three standard transmission voltage level, which is 132 kilovolt, 275 kilovolt, and 500 kilovolt. High voltage direct current line or HVDC. So they are different compared to HVAC. HVDC meaning that the power is transmit in DC power. Okay, HVDC lines are typically used in two situations. The first is actually where the transmission of the power is extremely long distance, and the second is actually to connect two different power systems that has different frequencies. For example, we have HVDC transmission line at Gurun, Kedah, okay, in Malaysia, where it connects the power system from Thailand to Malaysia. Okay, why we need this HVDC? Because in Malaysia, the frequency is 50 Hertz, while Thailand is 60 Hertz. So there is a what we call the power trade, okay, power purchase and power buying from these two countries. For example, if Thailand has a surplus power generation, it can sell to Malaysia. Okay, but in order to sell that one, it need to convert into Malaysia frequency, which is 50 Hertz. Okay, and also Malaysia, if there is a surplus in generation of the power, it can sell to Thailand. Okay, but it also need to convert from 50 Hertz to 60 Hertz. So this HVDC transmission line provides that interface. type of transmission line. So to transfer power at long distance, it is more economical to utilize HVDC rather than HVAC. Okay, but even though the cost to provide the DC-AC conversion, okay, because HVDC involve the conversion from AC, okay, for example, from Malaysia is 50 hertz, so it convert into a DC, and then from DC it will actually convert into an AC, but with a frequency of 60 hertz. So it need a converter, AC to DC and DC to AC. Okay, so this is AC to DC we call a rectifier, and DC AC is what we call inverter. So the cost of these two converters, even though it's very high, but it can be compensated by relatively low cost of HVDC line construction. And there is no significant magnetic and electric field, okay, effect from the line to the environment, because this is DC power, so there is no inductor and there is no capacitor. Okay, so it only consists resistor representation model of the transmission line. Okay, and furthermore, the problem of voltage regulation and reactive compensation are not the issue in HVDC. There are various types of overhead transmission line structures available. The tower is normally constructed from concrete, steel, and timber. In Malaysia, the towers are commonly constructed from lattice steel. The structure is very strong and relatively lighter and simple to erect. However, the design and fabrication stages are complicated and time-consuming, while the base for the tower requires significant land areas. So this is actually the structure, the typical structure of a Malaysia power transmission tower. Okay, so I think it's better for you to know that, okay, to know the components or the element that actually associate with this tower. Okay, so the first one is what we call the suspension insulator set. This is the pin insulator that actually insulate the cables from the tower. It is actually constructed from porcelain or glass. Okay, the second one is the conductor itself. Okay, the phase conductor itself. And the number three is the spacer. So this is actually just a spacer to avoid the line transmission to touch each other. And also you need to know that, to remind to you that actually the conductor is actually a bare conductor. There is no insulator. So it is better to make sure that there is no touch between the cables. The fourth element is the shield conductor. The fifth element is actually a set of three-phase conductor on a tower, which is we have phase A, phase B, and phase C. The sixth is actually identification plate for the line, okay? And the seventh is the security features, again, unauthorized climber. Okay, so actually for the transmission line, we can analyze the performance of the transmission line by actually modeling the transmission line based on based on what we call resistance, inductance, capacitance, and leakage resistance. Okay, and this actually, for example, the magnetic and electric field. Okay, the transmission line also developed two types of field, namely the magnetic field and electrical field. So actually, the magnetic field is developed because of the current flow inside the cable. So by using right-hand rules, so if you have a current flow, you will have a flux, okay, which is developed surrounding the cable. So this is actually will develop the what called the magnetic field. Why the electrical field is actually the electric the field that actually developed because of the voltage from the line, the phase A and phase B. So it will develop this what I call electric field. And this electric field is actually we can represent by the by the capacitor. While for the magnetic field, we represent as a inductor. Okay, so this is what we actually tried to describe earlier. So this is the conductor. As you can see, if you have a current, so we will have a magnetic field surrounding. Okay, and this between conductor, so it will produce what I call electric field. Okay, and